Hey everyone, this is Work Items API Performance Working Group. Today is Tuesday, 11th of March. And let's maybe start with quickly recapping what happened over the week and kind of what we discovered, since that kind of was the main theme from the last meeting. And feel free to just move items from the bottom, like Alexander, I think yours fit in well with this
Yeah,
topic.
so I'll verbalize and then I'll add an issue with a little bit more detail here, but just to give you some understanding, like I took last time an action item to see if there is any if we shave off some of the permission checks, how does that influence the query times in general? Because like we do some of the permission filtering in the finders anyway, and then we do that in the GraphQL as well. So that feels kind of duplicative. So I've gave there some context. I just increased the number of items returned locally. I don't have a big database locally by any means, but just to exacerbate any kind of gains that I can see from that is like I want to return as many items as I can fit. So basically increase that to 400 items versus I think we have 100 today on production. So for that, my query locally is running 11 seconds. Like the query in the networking is showing 11 seconds, right? Which is crazy. The database in progress bar is like under 100 milliseconds, 60 milliseconds, like 50 milliseconds. So all the time is spent in GraphQL middleware or like CPU, garbage collection, all that stuff, right? So in terms of skipping the permissions, we have that helper desk skip type authorization where because you load the items and then each type checks basically every object instance the type again. That was shaving off around 10 to 15%, like 1 to 1.5 seconds off of that 11 seconds. So there is some gain, but like not exceedingly much. And then the next radical thing, I was like, okay, what if I remove widgets altogether? Like I will only load whatever the base types are there on the collection, and that reduced it to like around 50%, right? So a lot of the time is spent within the widgets themselves. Like the next thing was like, what if I load just the empty widgets and not like all of the data, just basically the interface, right? So all I left is the underscore type, which is the GraphQL's way of saying this is the type of the object. And that was not reducing like the same 50%. I was expecting that like there should be close to no overhead, where instead it was like more of like it was around 8 to 9 seconds returning like pretty constantly. So that kind of tells us that there is a lot of overhead coming from the GraphQL itself, or I don't know if we have some objects that we initialize within the GraphQL, or that's just the gem how it works. Like we need more to dive deeper into that, or just I don't know. Maybe there's a case to be made to move off GraphQL for that completely. I don't have a good answer. It's just like what I found so far. And I'll add some of the flame graphs and whatnot, what I have into a more detailed issue. I just didn't have the time to do so yet. I'll formalize it in a bit better way.
Should I move to mine?
And yeah, if you don't have any questions or like maybe some clarifications, then we can move on to the next one.
Yeah. So on my side, I added some information about removing widgets from the main query of listing work items. So in that case, it confirms that linked items is one affecting the query the most. Second, it would be labels, but mainly in the group query. When we include projects, I tested that locally, and that was the biggest difference. In the information you can see there, we go from timing out in the group query to actually returning So, and this another one, I added this point later, so maybe I can extend that later. And then we discussed the children list as well. That was quite slow when we included widgets in the hierarchy widget. But so in that case, I confirm again that the slowest queries were for rollup. So we have weight, health status, and the count of children. The question about this is if we want to include in the scope of this group working on other queries that's not the main query, because I was a little bit confused about that. I saw some comment that said that if it's for example single work items having performance issues, that's something that we're not going to deal in this group. So I'm not sure if you want to include this or do more research about it.
That's a good question. From what I gather right now, the most blocking problems for us are the lists, right? Kind of blocking all these like tier deliverables for assets, GLKL, but whatever. And how, if we're looking into the single item, is there any, like, what is the benefit of looking at it right now? Like optimizing, making it better, obviously, but
Yes,
is there
and
anything pushing us?
in a specific case of children, we've been looking at it from the error budgets. This is affecting the error budgets. We already had some focus on it, and we were trying to improve. A lot of it is very unperformant, like moving the children. So I think like even if we don't pay attention to it during this group, it will still be handled for other reasons. It would be mostly if this was affecting using other features that's not listing. This might even be a problem when we deal with boards, but that's not yet. So I think it would be okay to leave it out and focus on listing work items. I'm not aware of any place where we list work items now and we include the hierarchy widget.
I think it'll be fine to include it, but as a kind of lower priority goal. That like mostly we are focusing right now on the listing of items, but we can also discuss and like it may also be related, right, to some of the other work that we do anyway. So
just wanted to clarify. So the children thing, like the rollups, they're mainly for the hierarchy list, right? Like the widget, and not for the listing page. Or do we have plans to show it there, or like?
I think I'm not sure what we used to include. I know that in boards we will include the number of children of each epic, so we used to use the count. But I think we also include the progress, so the weight roll up. But in the listing, no. What I remember is that we used to have the blocking and blocked items, so the linked widget. Even if we remove it now, we probably have to add it later. But yeah, for rollups, I don't think there's any use for it. But maybe someone from front end will know better. I don't remember how the parity of the other lists look.
Yeah, I just remembered that we added that for the hierarchy, so I was just wondering. But I think one of the good things about this children thing though is like we have a way forward. Like we have the epic for like caching this in the DB, and like
Yeah.
it's just it just takes a lot of work. So it's not probably not like a working group thing, because working group for me, I think it's more of like exploring the solution, and this is more of like implementing the thing, and it's more like planning who would do it, right? Or something, allocating like engineer hours for that. But
I'm not sure if we are going to touch anything about mutations performance. We haven't discussed that at all, but that is also another problem in children. The update mutation for work item can be very slow when you are depending on the widget, but yeah, that might be just outside the scope as well.
Heinrich, do you want to
Yeah.
verbalize the next point?
Yeah, so I just did some experiments on the main query that we do. Like, I can actually list them down here. I could share my screen maybe. Yeah, so this is I started with a project level query, and this is how our query looks like right now. We filter by work item types because this is the query that Nicholas was measuring, right? This is the same query the GraphQL query makes. And the main filter here is like this one, yeah, because we have a set of types that we want to show on the issue list today. We exclude requirements and epics and test cases, I think, or something. But and the other one, the banned users one, was what like Nicholas also mentioned the last time. So we look at the query plan. It's not the slowest, but it's also not the fastest. We could see that it's queries by work item type, project ID, state, but the main problem here is that it fetches all 75,000 open issues of this project, and this takes most of the time. After getting the 75,000, it pairs it with the banned users. This is a 75,000 loop just to check each one if they're part of the banned users. And then it sorts the 75,000 so it could get the first 100 graded at. So that's where that's the sort of problem we deal with the group level queries, right? It's similar. So it's like the main issue here is like fetching everything. So I did some tests here. First, I tried removing the work item type filter, and I was surprised that this actually much faster. The buffers were much smaller. What happened here was that it scanned this index with the sorted list already, so it didn't have to fetch all 75,000. Fetched it in parallel, and then still the same thing, matched it with the banned users. But since Postgres is working with a sorted list already, I think he's just getting the first, here it's like 3 times 47, so it's like 130 something until it gets 100 that it needs. That's why it's much faster. Removing the banned user filter, this is what Nicholas mentioned before, like also mentioned, similar thing happens here. So an index makes you fetch the 100 instead of the 75,000, and it's much faster. So that kind of like frames the problem, right? The main problem here is like fetching. We have to frame the query in a way where we don't fetch all the items from the DB. And here's another experiment also, because I noticed that we were filtering by this base type thing, right? Joining to work item types and base type in this array. We don't actually need to do this because we know the fixed IDs of each type. We could just do issues.work item type ID is equal to these IDs. It could be a subquery. In this case, I just put in all the IDs, and Mario also worked on like this is now fixed 1 to 9 today, so it's kind of like easier. In this case, it still fetches all 75,000, or in this case, I think it's 67. I don't know. It's like fetching and then pairing with the band right away or something. But then it does it in parallel. And based on some tests, it's like the execution time is a I wouldn't say like significantly faster than the original query. So I'm still exploring this, if this is worth doing and how. I'm testing this with queries with like label filters and all that, and maybe I haven't gone through the group level. So that's one area I'm looking to explore in other parts of it. Yeah.
Yeah, just one question. This looks like a simplified query of, oh, this is the project level on one specific project only, right?
What? Yeah, you were cutting out. What was that?
Yeah, I'm not sure what's going on because I should be having the good internet. So that was the query for just one project. That's not even like that's not coming from that's not even the issues query on the group level, right? Where we filter where we only query project level work items.
Yeah, this is
Okay.
the project level query for now. And yeah, I forgot to mention one reason the project level is much simpler than the group level is that we do the permissions check for project level queries outside of this query, right? Because there's only one project. We just do like can read issue like project, and once you can read it, then this is the query. For a group level, it's like query all the projects with under this group or all the namespaces under this group, plus with the clauses there for the permissions check and all that. So yeah. So I'm starting with this and seeing like how it works with other queries too, like the other variants, like the group level. But like I said, like the DB part right now with the project level isn't the biggest chunk. Like I mentioned this in another point, like the lowest hanging fruits, there are bigger gains to be had with the N+1s and all that. So I'm not sure if it's worth like pursuing really these like tiny gains here, but yeah, this is just something interesting I looked into this week.
Yeah, that makes sense. Like I wonder if there are more gains when we go into group level queries where we can do more, like we can optimize more of that stuff. But yeah, that's interesting. I also feel like we should be able to remove those type filters when because we are talking about the unified work item list, right? So at that point, like we should be showing everything. And then when we want to render specific stuff, that's when we can decide, is it a work item or is it a legacy visualization of that, if it's a test case or I don't know what, but we can still, I think, put it all in the one query, but then you'll have filters by type anyway, so we'll have to deal with that.
Yeah,
anyway
users
at some
could
point.
filter by type anyway, right? Like the filter.
Yeah,
But
yeah,
that's
yeah.
also a very good point. That's one of my questions also, right? Like regarding our goal right now, what's the query? It's the same question. What's the query we want to optimize, right? Is it the future query where we have a consolidated list, or the query we do now with these like restrictions, right? Like work item list with epics only. To replace the epics list, there's this issue list today that's filtered by certain types so that it matches the old behavior. Or do we optimize for the future consolidated list?
For everything.
I have the impression that there's some types that they're always going to be filtered out, like requirements, because they live in a different menu. So I think the consolidated list is more for issuables, or well, in this case, tasks, issues, epics, but I'm not sure if they will include even maybe objectives that would have a different menu. So we might have to keep filtering this out.
Yeah, it depends on the product goals, right? Because if we see that the long term, these types are always going to be like out of the main list of types, then an index with targeting those specific types sorted by graded at, just for the default view would help. But yeah, it should be like if we know the certain types we want to list and how far in the future we want to like integrate requirements here, or would it be never, or what's the answer to that question?
I think, yeah, we really need both. Like right now, we need to address the problem with current UI and with just migrating to the work items API. So maybe what you suggested was just creating specific indexes for current queries will work, and maybe we can have them in parallel, kind of indexes for new queries and the current ones. At the moment, kind of my hunch is I want to focus on what we have now and what's blocking for the closest roadmap items like epics lists on projects and issues lists on groups, etc. But I may be wrong.
Yeah, another question is probably, and that'll kind of transition us to the yes thing, is there, or can we find some bounds and say, if you have more than, let's say, 10,000 work items in general, then you're better served off by querying it through advanced search, which is Elasticsearch. So then you need to do a little bit more infrastructure maintenance and move on to that, right? So, because like these queries may be serving just fine with all the filters if you have a limited number of work items, and then we can do that in PG and all whatnot. But then if you are over this limit, you'll see the sufferings with the performance, you'll see all of these issues, and then you're better served if you'll go and install and index your stuff in Elasticsearch. And then that's where we can move on to the separate code path where we support the bigger stuff and searching with all these types of filters and whatnot in Elasticsearch. That makes the assumption that Elasticsearch just magically solves it all for us, like in a very performant way, but that's yet to be validated, so to say. But that's where I think we can transition to this Elasticsearch, unless we have anything else on the queries.
I actually wanted to just ask, what's your hunch? Like after all doing all this exploration with databases and GraphQL, what I see, what you, Alexandru, just said is that most of the problem is coming from the GraphQL and widgets. What is, you can see in the Nicholas's charts is that, yeah, like database is also like 40% of the time in production. So my question is the current API, the old issues API, and epics are affected to the same degree? Or once we switch to the work items API, everything suddenly becomes twice as slow as the current?
Yeah, I think I didn't look specifically at the work items API. I know that we have this issue. We had this issue with the nodes API, where in REST it was much faster than through GraphQL. So I would assume we'll see the same problem with the work items, where like if you're doing it through REST, it's faster. But again, the assumption at the time was that in REST you do basically, or most of the permissions and all that checks once, and then you just present all of the data that you've validated as being accessible. Whereas in GraphQL, you do it a lot of times through all of these types that you render in the tree kind of structure, right? As you go deeper into a node, you kind of check it again and again. That was that, but it seems that there is more overhead than just the permission checks. There's overhead and just building these nodes in GraphQL itself. So I think we'll see more slowness as we move to the work items. For the database, I don't think that's that simple, because there is overhead in the database as we move towards the group level. Like as we move towards group level and also group level work items, there is more database overhead that may come into play, and it will not make GraphQL look as bad, if that makes sense, right? Like it will take quite a bit of time. Like I've seen on production queries that take like 4 seconds or something like that to return from the database, right? So now if you compare that to the 10-second return or whatever from GraphQL, then it doesn't look as bad, but it's still, there is GraphQL overhead for sure.
Yeah, on the DB side, I think so. I on the old issues like endpoints or APIs or even the GraphQL endpoints, they're, I think, more optimized. Like we just use them longer. We fixed the n+1s. So, you know, if we switch, we'll probably find more n+1s we didn't account for. But in terms of the query, they will be pretty much similar if it's at the project level. At the group level is where it complicates things. Especially if we want to do the consolidated thing where group and project level are returned in one query. That's why we temporarily actually added a argument there for the work items query where you could say exclude projects true, so that you could only return group level items. In some of our tests earlier, we found that this was much faster for now, and this unblocks the work to switch epics list into the work item list. But if we want a consolidated list, or the work Alexander's doing on the project level epics and the group level issues thing, and we want them listed in one list, then we'd have to solve that problem still.
Yeah, and for the group level where we exclude projects, that's only faster because we have very, very few group level work items, right? Like we have orders of magnitude less epics than issues. So it just has to, like it efficiently filters by the whatever group there is or namespace and returns it a bit faster. Yeah. So yeah, let's move on to the topic that I'm kind of excited about with the Elasticsearch. And we've got Dimitri here standing for like 30 minutes. So I've put it on our topic too. I do have some questions, but I think the more generic question is like, can we rely on AS being much faster than Postgres in a lot of these bigger data queries, sort of to say, right? Like where you need to also search the depth of the hierarchy tree, and with a lot of these items. Obviously, there are questions in terms of, can we start using it all over the place, or is it like what are the restrictions, like paid tier versus not paid tier, and so on and so forth? Like I think there is still a bunch of stuff missing from ES. Like I didn't see filtering by milestone. I don't think we index milestone data and all that stuff. And then yeah, there's a lot of these questions. So the first one is like, is it a paid tier, or is it available also in FOSS?
Yeah, so answer that it's paid and registered. So, but we have, I think, several issues to actually make it available in FOSS.
What does registered tier means?
I think you can use it for free, essentially, if you agree to send some telemetry data, if I remember correctly.
Oh, okay. I didn't know that. Yeah, so I think we can skip all of those questions. We've got the answers for that. It's like the bigger a question, I guess, is like, if you were to, Dimitri, if you were to like come to Plan Team now and say, okay, we wanted to use the Elasticsearch, like what would be your say, okay, I need to understand these restrictions in order to tell you if it's a good fit or not so good fit? Like, do you have any concerns in terms of like us starting and using that? Like what questions should we ask ourselves, right? So what I'm trying to uncover here is like, what are some of the unknowns that we need to look into and investigate? Do our kind of part of the work, right? Like you need to look into this and this and that, because like it probably will perform okay, but maybe not. You need to investigate.
So in my mind, it will be much, much more performant, given how much our team struggled with Postgres, especially with group level searches. I think that's really important for this working group. It's to search something in a namespace. And I think Postgres just doesn't really work for that use case. My main, not even concerned, I think the main challenge is finders. If we want to support both Postgres and Elasticsearch, we'll need to change how we operate in regards to finders.
So I've even opened a design document recently that we need to not return active record scopes. We'll need to return actual paginated results if we want to support both backends. So that's the main challenge in my mind. If you want to migrate towards that new world, when if you have advanced search, you're using advanced search. If not, you're still using Postgres. We need these new finders because our team has been.
That would mean if we wanted to be like transparent in the sense that user doesn't have to know which backend it's using, right? But if they have to make the decision explicit, then you can have different finders for the different use cases, like, right? Is my understanding correct there?
Potentially, but I was hoping that we can make it more transparently. Maybe
Yeah,
we can
yeah.
start.
I mean, there are obviously pluses for that because you can have one front end dealing with the two backends at the same time. It really comes down to what's the cost, right? Can we implement such finders easier, or is it easier to have two front ends basically dealing? One will deal with the active record scope, another one will deal with the just an array. But yeah, I'm just trying to understand what's your vision in that, and that's like we want that finders if we want one front end, and then the back end is basically transparently moving between. Oh, I'm actually will be much more performant to use Elasticsearch. So the decision is not on the user, but it's rather on our own backend. Okay.
I was thinking we will have maybe a set of filters, advanced search finders support. Maybe we don't have milestones yet. Then we will fall back to using Postgres. And then we can migrate all these fields to the advanced search finder, kind of. And if all of the filters are supported, we just use advanced search. I think it will always be more performant than Postgres.
But we don't have yet any examples in GitLab that uses both and does this fallback, right? Like there is nothing that does that today.
So /search page does that. If advanced search is disabled, we use Postgres. So we already kind of do that. But
yeah, but the decision is on
feature.
The decision is coming from the front end, right? It's not a decision that's done on the back end itself. It's like
It's
I'm
actually
sending
on the backend. Yeah.
Okay.
If you don't have advanced search enabled, we just use Postgres. We call it basic search. It's much, much slower, but it's available.
Yeah, but does it like go through the same, like, what do you call it, like a finder code, or like it's just a different HAML, different finder, different everything? Like,
So it's the same HAML file. We use search services, and these have kind of this decision tree, whether or not Elasticsearch is available, whether or not this specific thing is indexed in advanced search. And then we decide which backend we should use. But it's very search specific, so that's why I'm talking about finders. Maybe you can utilize finders to use it more broadly in GitLab.
and the link you posted is the wildcard search, so I'm assuming like it could also eventually replace the list view, like even without filters, right? Like,
Yeah, I believe so. So we have an old epic specifically about that, about using advanced search with merge request lists and issue lists. But we haven't prioritized it. I think this working group might be a really good opportunity for us to actually pursue that.
my only concern is, it's not really a big concern, but like, if you look at the issue list right now, there are so many like edge cases, like sorting by priority or something. So should we index all the label priorities and all that in ES, and to sort through that, or like, those are not very commonly used, but if you want like full parity between both, then we'd have to handle these edge cases that we need to support.
So Elastic indexes all the fields. So it's just a question to add these fields to Elasticsearch, to our indices. we have advanced search migration framework, which makes it really easy. So you add a field, you backfill it, and you can use it as soon as the backfill is completed.
Yeah, but this, like, for example, a complex search is like I said, priority is like depends on the issues labels, and the labels priority set somewhere else, right, in another table. So if those priorities change, this issue list should change. It should like trigger a reindex or something, or should we just, those kinds of things.
Yeah, I think we have something similar when, let's say, project permissions change, we reindex all associated documents. So I think it's pretty similar to that. We'll need to denormalize some fields to Elasticsearch to this index because we can't really do joins in Elasticsearch.
The other thing I remember from the last conversation I had with the ES thing before was the cost. I think the ES team mentioned that before that we were not ready to handle, much more ES queries at that time. I don't know the current situation though.
I think it's much better now. So more than 90% of our storage is code, and we have Zook now, exact code search, which will kind of replace advanced search for that. And I think other document types like work items are negligible compared to code. So I have a huge cluster with billions of documents in it at the moment.
Is there anywhere where we can learn about like performance of re-indexing all this stuff? Like going back to what Heinrich just mentioned in like you've changed the priority, so you need to change those indexes to basically re-index a bunch of documents, and that will come also true because we have this like custom work item types. So your type is currently called issue, but then it becomes being called, I don't know, feature. So you basically need to add that data to the Elasticsearch now, because it has been saved to the database, right? You need to do this whole migration. My question is like, how much data can we process in a unit of time, or like some kind of performance understanding in that, how fast that can be available in searches, right? Because like you've changed it, and now you need to be able to work with your boards and everything else at the same time. That's something that we still need to solve for Postgres as well, and we're thinking about this decorator pattern where it propagates the change. Like you did not yet change the type itself, but you can see how the change is being applied. So maybe we can do some magic in that context, but maybe we can just re-index it at the same time and return it.
I think it should be fine. Right now, the delay is up to a minute, but we can easily change that to be several seconds. So if we don't have, oh, sorry.
So you can index like what, like 1,000 issues per minute, or do you have any kind of understanding of how? Obviously, it depends on how much data that is, or maybe in megabytes we can say you can index like 1 kilobyte per second or something. Do we have any kind of measurements in that sense?
I think we have it saved somewhere, but it was really, really high. We paused indexing for, I think, a day or two, and then we processed the entire backlog, maybe 500,000 of documents or something, maybe in 10 minutes. I don't remember specifically, but it was really good. And we have sharding. So we have 16 shards for indexing. So if we see that the current throughput is not enough, we can just add more shards. But we've never had problems with indexing throughput.
And one more question. Would plan-related stuff be on a kind of separate cluster, or is it all within the same? So what I'm trying to say is like, if, code is probably is going to be separate in Zooked, but if some other part of the search fails, will plan be affected, or can we make it so that like wikis cannot be searched, but issues can be searched, right? Like I think we need a much higher availability for issues than something else in searches, because it affects like boards, lists, all of that workflow. So my question is, can we have it separate, or it has to, like the current architecture is everything has to live within the same infra?
So that's possible, potentially possible, but right now it's a single cluster with multiple nodes. We have work items index. So if something goes wrong with the cluster, it would potentially affect work items as well. But
Makes
we
sense.
could discuss maybe some mitigation strategies if we want. Also, we could potentially fall back to Postgres if something goes wrong, so that we can at least still maintain the functionality, even though it won't be as performant.
Yeah, the worry is that we will not be able to maintain like same kind of UI and features, like the same boards and all that, if with the two backends, right? Look, I can see a world where you can have a simplified UI and features versus if you have Elasticsearch, you have a lot more stuff going on there. And when that falls, it will just not serve the same board, right? That board will have different configurations and all different filters, different everything. So it'll probably not be as easy to be as transparent, because I don't think we can support everything in both places. But yeah, anyway, one other question that I have is about custom fields. And I'm not sure if that's something, if that will be a concern at all for Elasticsearch in that it's not exactly dynamic. We kind of know the name of the field, and we know the type as well, because we wanted to know like the type of the field in the database anyway. But I don't know if that raises any concerns to you as well, or I think you've answered, but I didn't catch it.
Yeah, so we could potentially add a nested field, a nested object field, but I think we might want to discuss to think on that separately to see the maybe requirements for custom fields, whether or not we want to introduce these dynamically, or we know all the fields and we can add them to our index in advance.
No, we don't know the fields. They will be defined by the customers. We know that we have a limited set of fields, like we only can have 100 custom fields max, but then those will be added dynamically by the customers. Like they can have 2 or they can have 20. We cannot know. At least that's how it's designed today. Maybe we need to revisit that, but yeah.
I see. Yeah.
And we need all the functionalities on an ordinary field. Potentially, it's not going to come all at once, but we would want to be able to filter, to sort by them, to group by them, and all that stuff.
Yeah, we have quite a bit of the agenda ahead of us. Can we maybe move to the next points?
Thank you.
The next one is, I think mostly it's covered, but like I mentioned, like it's not really the DB that's the biggest chunk right now. Is that the linked items N+1? I think it's assigned to Eugenia, so she's probably working on that already. And like there's another N+1 on the redacted user, which is like more of a problem for our project, because we have a lot of like bot created, like the test failure issues, and they're all created by the bot. And every time there's a bot user, we check if we have access to that bot's project, so that we can redact the name if you don't have the access to that project. And like, yeah, it creates these N+1s. And
If there are no comments, Alice, I guess you have a next point.
Yes. So after the last session, I think for me there was a lot of listening, but afterwards processing it all, I was like, there are so many of the raised issues that can be potentially fixed with Elasticsearch. And that's why I asked Dmitry to have a call, and we started discussing it, everything, probably mostly from GLQL scope. And yeah, I realized that like there is a lot in place that we can potentially start using. And I thought like it's important just to narrow the scope, because we're now discussing so many things, and if just like trying to grasp everything, it might be overwhelming. And then also another thing, I think Heinrich, you mentioned not everyone has Elasticsearch, because you were considering this before, and not everyone has Elasticsearch on self-hosted instances. But then again, if it's a bigger customer, they're potentially already using Elasticsearch, and they will actually might like this possibility to scale for them themselves. And then optimizing thing for GitLab.com, that's already a huge win. So I thought of focusing on subgroups, like searching through different subgroups, because specifically for GLQL, like one of the biggest advantages of using it in one place, you can have you can plan your work through different hierarchies, different namespaces, and at the moment this most probably is going to timeout. And doing this through Elasticsearch, possibly it's going to work pretty fast. And Dmitry already mentioned that they did quite some optimization for this in Elasticsearch, because code team are already also using this for their purposes. So I created a proof of concept issue for us to start collaborating, and yeah, try to connect it on backend for GLQL if Elasticsearch is available. Then also feature flag, potentially also maybe some URL params, so that like if feature flag is enabled, we can switch to GraphQL, then Elasticsearch, and just to see like what's the time difference, how like are the results similar, and maybe having this small step of us connecting it, then we can build on that. Yeah, I think that's like the overview of the potential thing we would like to try out for GeoQL.
Yeah, I think that's a good idea to have some sort of a proof of concept with the Elasticsearch. What I would suggest in a way is to pick something that we have in Postgres and then try to do that same thing in Elasticsearch, so that we can compare somewhat apples to apples. It's not going to be apples to apples, obviously, because like the two backends, but as close as possible. So then it will be an easier, like you already mentioned, it will be an easier comparison to understand like what are the potential gains and whatnot. Because otherwise, if we do it totally different, it will be kind of different. It will be also a easier sell, I would say, to product as well in all that. If we see a nice performance improvement and all that.
Yeah,
So yeah,
that's a good suggestion. I think I did identifying slow queries, which for which the fields already exist in Elasticsearch, just not to spend time on reindexing data. So we'll try to find slow query, which data is in Elasticsearch, and we'll try to replicate that.
Yeah, like even adding something, I think locally it should be pretty fast. And again, like if that's something that locally is slower, you gain locally like X times the speed, then that's also a good proof, I would say. And then we can expand it to a specific group in production or whatnot.
Dmitry, was there anything I missed and you wanted to add? Because we discussed a lot of things last week.
Maybe only one question. Do we want to focus on namespace searches? So is it possible to include subgroups for GLQL? Maybe we can have side by side, because I think Elasticsearch is the strongest point is for namespace searches.
It's possible, and I think what we'd want to actually look into is a unified query where we get group level work items and project level work items, and you query them, for instance, from GitLab work level, right? Some root level group, and now you want give me all the epics issues and tasks, for instance, right? With these filters, I don't know, maybe labels, maybe I don't know what we have in Elasticsearch, but some kind of a query that we can build. I think we have work items route today at the GitLab work group level. So then you can build some sort of a query and see what the Postgres and what the GraphQL is for that, but not as like simple enough that it can be replicated in Elasticsearch. But at the same time, it will probably take quite a bit of time to return results. That having said, it still sounds like we should try and focus some of our time into improving the GraphQL overhead, because like regardless if it's going to be through the Postgres backend or the Elasticsearch backend, if we are going to use the GraphQL API to return, or the GraphQL as a front-end interface to return the data, is like the overhead is quite big. So yeah.
Actually, I wanted to kind of fix on the action items for the next one. So it looks like at the moment, Heinrich, you still be looking in the slow kind of the database side of things, right?
Yeah.
Potentially on the group level as well. Yeah. And Alexander, do you still plan to investigate the GraphQL further? The overhead thing?
I don't have much there. Like I've hit a bit of a wall because I don't understand how we can, like all that I'm seeing in FlameGraphs is GraphQL internals basically. So I'm not sure like what I'd love to pair with someone who has more knowledge into GraphQL potentially, where I don't know. Or I'm open to collaborate with whoever has more knowledge into GraphQL, but otherwise I don't know what to do there. To be honest, I'm kind of stuck into improving the GraphQL overhead on its own.
I think we need to clear out the N+1s first before you can get a better picture of the flame graph, and like, because with N+1s there are repeating parts, right? So it's kind of like hard to see
I've
the
removed the N+1s from my query. So like in my testing, I actually removed the linked item so that I'm not affected by the N+1s, because I've discovered that as well. So I just removed that widget altogether. So I'm not seeing N+1s on the database side for myself on my local testing. But again, the overhead is just like immense. Like 50 milliseconds on the database side versus like 10 seconds or something like that to get that data out through the whole query is just too much.
It's interesting to say you don't see any N+1s besides the related links, because there are, I think, many in there.
No, I'm not seeing them in the database. I don't, maybe the data that I'm having locally is not returning some of the results. I don't know. I don't have the data. Maybe that's why I'm getting that. But yeah, I didn't see any of the obvious N+1s.
Is there anyone here who has more experience with the GraphQL internals? Or do you know anyone in GitLab who would be good to pair with?
Maybe I can help with that. Like I've looked into the tracing code stuff, so I'm also curious about the thing that you said about the difference you see on like how long the DB returns the data versus, you know, how long it takes to serialize the data to this JSON thing. So I think
Yeah, I can put something on our
on the nodes thing, right? So it's like this is a similar thing, and yeah, we could.
I can put something on our calendar, and at least I can present what I have, and then we can see how we can split the work or what we can find. But yeah, I'll take that offer, and sure, thanks.
Cool. So yeah, from now on, the action items, Heinrich, you looking at this SQL, Alexander and Heinrich, you together looking at the GraphQL, Eugenia, as I understand, focusing on these N+1s, right?
Yeah, the linked items ones is the one I'm focusing on now.
Yeah, and Alisa is working on the Elasticsearch POC. Anything else from the, like, what is everybody else wants to work on?
Something I found earlier when testing the difference with widgets is considering the queries when we don't have a current user. So in some items are still accessible because they're public, and so I found we have a bug now that we're not we don't have access to these items. But once you fix the bug, those queries are really, really slow, and I don't know if something that we want to consider eventually, like about 20 seconds, some of them. And I think it's because maybe I don't know, maybe there's something we can improve there, maybe even in the finder of returning things earlier or doing less authorization. Something to consider, maybe less priority.
I think that's overlapping with the work that I was wanting to work, that
Yes.
issue related to when the user has access, doesn't have access, or is not authenticated. I haven't started that yet because my pipelines are all red, but I think it's overlapping there, right?
And one more question from my side. Do you think it's worth it to look into the banned user denormalization?
Yeah, I looked at the queries and like it's not right now. I don't think it is a feasible thing because like earlier I was showing them like the comparison between adding a work item type query, because the default right now is we have a work item type ID clause and the what's this banned user clause, right? So switching that exists query into something like a issue dot hidden equals false or something, if we denormalize that into a Boolean, right? It's gonna be similar to the two clause thing where you can't have a single index. I mean, you can if you add an index for everything, you know, and add the hidden field on every index. But the main problem right now is that if you don't have this sorted index, then it will be fetching all the issues that match all the conditions and then sorting in memory. And I found that that's the slow part right now, especially with the group level when there are a lot more. So right now there's like, I'm testing on GitLab with 75,000 issues, and it sorts into memory, fetches into memory and sorts them. Takes like 500 milliseconds or so right now.
Okay, makes sense. Yeah, from my testing, the banned user query only performed better if I was able to denormalize it, like I used hidden or whatever, and then added an index on it. Before adding the index, there was no improvement, as you said. Yeah. Okay.
Cool. And we are at actually 10 minutes overtime. Any other like points that we want to discuss sync and quickly? No. Then thank you everyone for very productive discussions and all the work that you've done over the week. So yeah, let's continue. Looks like there is a lot we can do to improve there. Yeah. Bye everyone.